Okay, please, students, what we are about to do now is very, very important. It will help us in calculating wave speed. We want to talk about the relationship between node, antinode, and wavelength. Remember, node is a distance, antinode is a distance, and wavelength is also a distance. So let's see the relationship between them. This is very important. First of all, let us talk about AN. What is AN? We have AN, we have NN, and we have AA. What is NN? NN is this distance from NA, or AN is this distance from this point to here. So we say AN or AN. You can see that this AN and this AN, they are both the same length. So therefore, AN and NA are the same thing. So now, we want to calculate how many AN we have in 1 nm. We calculate how many AN we have in 1 AA. So, which means, number 1, how many AN are there in 1 nm? So let us see. NN is from here to here, but to count it, we start from here, go up and come down. So we can see that if we want to calculate the number of AN in 1 nm, we start from here, which is NA, and then AN. But remember, from here to here and from here to here are the same thing. Hence, from here to here can be called AN, and from here to here can also be called AN. So how many do we have here? There are 2. AN 1, AN 2. So therefore we say 1 NN is going to give us 2 AN. Let us check the same thing for AA. To check, we can use this AA from here to here to count AN 1 and another AN 2. Therefore, we have what again? 2 AN. So now, if there are 2 AN in 1 NN and 2 AN in 1 AA, that simply means that NN is equal to AA. Now, finally, let us see the relationship between NN, AA, and the wavelengths. We want to calculate now how many NN are there in one wavelength. But remember that our wavelength is the distance between 2 successive crests. That means from this crest to this crest. But to calculate the distance, we start from here, we follow this line, and we get to this point. So how many AA are there? We start here. This is AA 1, AA 2. So for this particular wavelength here, we have AA 1, AA 2. So one wavelength is going to give us 2 AA. Now remember that AA and NN are the same thing. So if there are 2 AA in one wavelength, that means that one wavelength again should give us 2 NN. And this is one of the important things in this diagram. Let us check out the 2 NN that will give us one wavelength. We start from this point. It is NN 1, NN 2. So which means we have a shape that looks like S. From here, we go up, come down, and we get to this end to get 2 NN. So which means that anytime we want to calculate the number of cycles using a diagram, we look at a shape that looks like this. So what it means is that whenever you see this shape, you call it one cycle, because one cycle is going to give you one wavelength, and also one cycle will also give you one period. Okay, now let us take, for example, you have a diagram like this, and you're asked to find the number of cycles in this diagram. We begin to count the S there. we count 1s, 2s, and 3s. So which means that in this particular diagram, we have 3 cycles. And this will help us in calculating the speed of a wave, and so on and so forth. Okay, finally, we are going to talk about the wave speed. What is wave speed? Wave speed is the velocity of a wave. And we say that wave speed is equals to frequency multiplied by wavelength. So therefore, wave speed of a wave is the product of the frequency of that wave and the wavelength. Mathematically, we say V, which is representing velocity of wave, is equals to F, which is the frequency, and lambda, which is the wavelength. Now, this is the standard formula for wave speed. But from other things that we learned under this wave, we can still derive or form other formulas. Like, let's take for instance, remember that when we did frequency, we said that frequency is the inverse of period. That means that in this wave speed equation, we can remove frequency and replace it with 1 over period. And that will give us that V is equals to our frequency will now be replaced with 1 over period, then multiplied by the wavelength all over 1. And here we get that velocity of wave is given as 1 times wavelength is wavelength over period times time is period. This is another formula for wave speed when the period and the wavelength of the wave is given. And finally, we know again that frequency is the number of cycles completed in 1 second. You can remember this formula from the definition of frequency. Hence, we can say again that velocity of wave, we remove frequency and replace it with n over t again, then multiplied by lambda over 1. We now get that wave speed is given as n times lambda will give us n lambda all over time times 1 will give us t. So from this, we have established 3 formulas for wave speed: frequency times wavelength, velocity, wavelength divided by the period, and n lambda divided by t. Let us take a few questions from this and see how it works. Okay, let us take a look at these particular questions. The first one says a radio station transmits at a frequency of 1.5 kHz. If the wavelength of the wave is 2 meters, calculate the wave speed. So we first of all solve by bringing out the parameters. The frequency here is given as 1.5 kilohertz. So the first thing we do is to convert this kilohertz to hertz. And how do we convert kilohertz to hertz? We multiply by 1000. Whenever you hear kilo, kilo means 1000. So kilo of anything means multiplying that thing with 1000. So 1000 kilohertz is going to give us, 1.5 kilohertz is going to give us 1.5 times 1000. Therefore, our frequency here is 1500 hertz. And the wavelength given is 2 meters. So we simply say that velocity of this wave is going to give us f lambda, which is 1500 times 2. And hence, the speed of this wave is 3000 meters per second. When we take a look at the second problem, it says a wave completes 1000 cycles in 5 seconds. If the speed of the wave is 3000 meters per second, calculate the wavelength. Now, in this particular one, they've given us the velocity of the wave, and we are asked to find the wavelength of the wave. Completing 1000 cycle means that n is equals to 1000. The time taken is equals to 5, and we are given the velocity as 3000. Now, the formula that connects these three things, we are looking for the wavelength. The formula that connects these parameters is velocity equals to n lambda over time. We begin to substitute. What is our velocity? 3000. We say all over 1 is equals to number of cycles 1000 times lambda all over the time taken is 5. This 5 can cancel this 1000 to give us 200. Therefore, we have that 200 lambda is equals to 3000. And if we divide both sides by 200, this 200 will cancel this 200. Hence, the wavelength is equals to 3000 divided by 200 is going to give us 15 meters. With this, we can come to the end of this particular chapter of Wave. Thank you for watching, and please don't forget to subscribe, like, and share our video. And for more questions, don't forget to check out the links below for past questions in WAEC, JAMB, and post-UME. Thank you once again for watching.